Okay, this group we call it as alcohol. So this we are converting into this, which is alkyl halides or halogen derivatives. Okay, so we also use hydrocarbons. What are hydrocarbons? It can be the alkanes, the alkenes, and the alkynes. So what's the basic difference between alkanes, alkenes, alkynes? So if the carbon chain, which is having a single bond, they are called as alkanes. If it is having double bond, alkenes. If it is triple bond, alkynes. So we are using the different alkanes, alkenes, alkynes, and we'll prepare the allo compounds. That is alkyl halides. Okay, and we will be using halogen exchange with different molecules, and we'll try to make Rx. So today we'll focus on how do we prepare from alcohols. Is that okay? So and then next class we'll see hydrocarbons and halogen exchange. So let's see how do we prepare from alcohols or using. So what we are preparing here?
Halo compounds.
What are halo compounds? That is nothing but alkyl halides or aryl halides. Okay, so we are preparing alkyl halides or aryl halides. So what are alkyl halides and aryl halides? The alkane group, if it is attached to the halogen group, so this is what? It's halogen. And what is this? It's a alkyl. So what are the halogens do we have?
Fluorine, chlorine, bromine.
Chlorine, bromine,
Iodine.
iodine. So we are either attaching RF or RCl or we are RI. Okay. So those are alkyl halides. Whereas aryl halides, we are taking the ring. We are taking the closed chain and you are attaching the halogen group. It can be the fluorine or chlorine or bromine or iodine. Okay. So this is what we are preparing. So we are preparing alkyl halides or aryl halides by using the alcohols. But apart from that, we also need certain reagents to do this. Okay. So to do this reaction, that is alcohol converting into alkyl halide. So what is this? It's a alcohol. And what is this? Alkyl halide. So this can be RF or RCl or RBr, RI. So what we are doing here, we are removing the OH group and we are attaching the fluorine or chlorine or bromine or iodine. So that how we are doing, that's a preparation of the alkyl halides using the alcohols. Okay. But for this reaction to happen, we need certain reagents. The reagents are, it's a hydrohalic acid. So what is hydrohalic acid? Dia? Dia, can you understand anything? What I'm saying?
Yes, sir. I am missing some stuff here and there, but I think that's because I missed the first class.
Okay. So just basically what is hydrohalic? Or at least tell me what is halic or halogen?
Yeah, I'm not sure, sir. I'm confused right now. It might just be because I'm put on the spot.
So just remember, halogens means fluorine, chlorine, bromine, iodine. Here itself I wrote. So what is halogens?
Yes, sir.
Fluorine, chlorine,
Understood
bromine,
that.
iodine. That attached to hydrogen, so it's making hydrohalic acid. So it can be HCl, hydrochloric acid, HF, or HBr, hydrogen bromide, or HI, hydrogen iodide. So these are the different hydrohalic acids. These are all acids. In that HCl, we know it's one of the strongest acid. Okay.
Okay, sir.
So we are using these HCl, HF, HBr, HI as a reagent for doing this reaction, or we are using the phosphorus halides. So phosphorus halides, again, the phosphorus with some halide like PCl3, PCl5. Okay. And we are also using the thionyl chloride. So thionyl in the sense it's a sulfur and chloride. So SOCl2, all those compounds. So first we'll talk about how we do with the hydrohalic acid. Second, we'll see about how do we do with phosphorus halide using as a reagent, and how we do using thionyl chloride and prepare the alkyl halides. So first today we'll study about the alcohol, from alcohol, how you are getting the alkyl halides. In that, how we use the hydroallylic acid to derive this alkyl halide, how we use phosphorus halide to derive this alkyl halide, how we use thionyl chloride to derive this alkyl halide. Okay, so we'll see three different ways how we prepare this alkyl halide using the alcohol. Is that okay? Everyone understood? Please confirm me yes.
Yes, sir.
Okay.
Yes, sir.
What శ్రీకర్ బొట్టు పెట్టి చెప్పాలేంట్రా చెప్పరా
yes.
అర్థమైతే ఎస్ అని
Yes, sir.
యా ఓకే సో లెట్స్ సీ హౌ డు వి డూ with the hydroallylic acid. So first we'll see just basic examples how we are doing this. So let's take, we use HBr. Please write this. These are the few examples how we prepare synthesize plus water. Remember, in all these reactions, water is the product that we get. Okay. Let's take another example, which is OH that reacts with hydrochloric acid, Cl plus water. Let's take another. In presence of hydrogen iodide, plus water. So these are the few examples how we are converting the alcohol into alkyl halides. So all these, on my left side, we have these alcohols. On my left side, we have alcohols. On my right side, we have alkyl halides. So see here, what is basically alcohol? Any alkyl group that is attached with OH, we call it as the alcohol. So you see here, this is one carbon, carbon, carbon that is attached to the OH group. In presence of hydrogen bromide, whatever the OH group is there, it is leaving and joining the bromine. And we are getting the water as a byproduct. You take another aryl, this is called as aryl, as it is a ring. If it is a chain, we call it as alkyl halide. As it is a ring, we call it as the aryl alcohol or cyclic alcohol. This is a aryl group. The aryl group is having OH group, and when we are reacting it in presence of hydrogen chloride, whatever the OH is there, it is replaced with the chlorine, and we are getting the water as a product. The same way here. So now tell me what you notice here. What is this carbon? How does this carbon is? It is attached to how many other carbons? Directly.
Wow.
Nitya, tell me whether it's a primary or secondary or tertiary carbon.
So what is the question again?
Whether it's a primary carbon or secondary carbon or tertiary carbon.
Primary.
Yeah, this is a primary carbon. So what is primary carbon? This carbon is directly attached to the another carbon. It's only the one carbon it is attached. So we call it as primary. But if you see this carbon is attached to two different carbons directly. So what we call this as the secondary carbon. And if you see this carbon, it is attached to three different carbon groups. Here R means nothing but the carbon chains. So as it is attached to three carbons, we call this as a tertiary. Okay. So remember, primary, secondary, tertiary, that's important as we go into deep. Is that clear, everyone?
Yes, sir.
Yes.
Just write these examples. These are some of the important examples or conversions that are given in your NCRT. If you guys wrote, just please confirm.
So what's the first one? I mean, it is open chain, right? What is it called?
Yeah,
What is it
it's a
called?
propanol. You can call it as propanol.
No.
As three carbons attached with OH, we call it as propanol.
It comes in the arene group, right? Arene.
Alkyl. It comes under alkyl. Alkyl group attached to OH. Aryl means it's a ring. Remember, aryl means it's a closed chain. You can see this is a closed chain. Whereas this one, it's an open chain. So you call it as alkyl. Alkyl means open chain. Remember this, alkyl means it's an open chain, aryl means closed chain. Or you can also call it as the aromatic compound. Whereas this one, the open chain is called as aliphatic compound. So what is aliphatic? The carbons which are open chain, we call it as aliphatic. They are also called as the alkyl. Okay, or alkanes, alkanes, alkanes. Whereas the aromatic compound, all those closed chains, we call it as aromatic. It can also be called as the aryl. Okay. And remember one more thing here. So all these are OH groups. The OH groups are replaced with a bromine or chlorine or iodine. Yes or no? So whatever this OH is there, it was replaced with bromine. Whatever this OH is there, it is replaced with chlorine. Whatever this OH is there, it is replaced with iodine. So what you can say here, when you react the alcohol with a strong acid, which contains the halogens, then those halogens are replacing the OH groups. That you need to understand. Okay. So remember this one point, which is very, very important. So whenever treating alcohol with strong acid, it will create a alkyl, or you can say it will create excellent leaving group. What is leaving group here? OH will convert into the water molecule and it will leave. So the OH will react with H plus and convert into the water molecule. Now this water molecule is a leaving group. So this reaction, when you treat an alcohol with a strong acid, it will create that leaving group, the water molecule. Okay. So what we are doing here, in place of OH, we are replacing the iodine. So this reaction can also be said as the substitution reaction. This is another point you notice. So this is also called as the substitution reaction. So why we are calling it as a substitution reaction? Because in place of hydroxyl ion, this is hydroxyl. And this is halogen. So in place of hydroxyl, you are putting the halogen group. You are substituting the halogen group in place of OH. So this reaction is also called as the substitution reaction. Or you can also call it as the nucleophile substitution. Have you guys know SN1, SN2 reaction? Have you studied in 11th? Nucleophilic substitution. Someone answer, guys. You guys studied nucleophilic substitution.
I don't think so. We studied in 11th, but this year when Sir was doing this chapter, I guess he thought.
Okay, we'll be discussing this nucleophilic substitution in detail next in coming classes.
Okay, sir.
Yes.
So we are just substituting one nucleophile in place of the other nucleophile. So that's why it is called as nucleophilic substitution. There are SN1, SN2 reactions are there. We'll study in detail what is SN1, SN2, and it's very, very important for board exam. Many times they ask the SN1, SN2 reactions. They ask like, explain what is SN1, what is SN2, what is the difference between SN1 and SN2 reactions. Okay. Mechanism behind the SN1, SN2 reactions. So that's very important. So right now you just remember it's called a substitution reaction because in place of hydroxyl group, you are substituting the iodine or chlorine or bromine, or you're substituting a halogen group. So that's why it is called as nucleophilic substitution. And why does it is happening? Because you are treating with a strong acid. So that's making a leaving group. And that leaving group will leave and it will replace with a nucleophile. Understood this much? Can we move to
Sir,
next?
I didn't understand the leaving group thing.
Okay, I'll tell you what is that. I'll show you in detail. So, reminding all, you understood up to this. Leaving group, I'll explain in detail in the next slide.
Yes, sir.
Okay. So let's see here. Let me write. So R.
So will you share these slides after the class?
Why you are not writing?
No, I am writing. I'm just asking. I'm also screenshotting. I just want exactly what you wrote. So if you don't,
Yeah,
if
yeah,
you're not
yeah,
sharing,
yeah,
I'll
yeah.
screenshot everything also.
I'll share. I'll share.
Okay, so thank you.
Okay, guys. At the end, just remind me. Otherwise, I'll not save this by mistake. Tell me what you know about the oxygen. What do you know about oxygen? So, what is the atomic number of oxygen?
8.
8. That is nothing but 1s2, 2s2, 2p4. Yes, yes or no? So let's see the outermost shell. The outermost shell containing electrons like this. Okay. In order to get an extra 2 electrons, this one and this one, the oxygen is involving 2 bonds. That's why oxygen makes always 2 bonds, O double bond. Or see, oxygen is making bond with hydrogen. So it is making 2 bonds so that it will get each electron here. Whatever that I mentioned in the green, it is not there. So the oxygen is trying to achieve that electron so that it will be having outermost electron 8. Right now it is having 6. If it gets the 2 extra electrons here, it will be turning into 8 electrons. So the outermost configuration is 8 and it becomes more stable. But if you see the inner shells like 2s and 2px, these are already filled. They are already occupied with 2 electrons. We know every subshell will occupy with 2 electrons. So the 2s and 2px, they both are occupied with 2 electrons. So we say these as the lone pairs. So remember, they are called as the lone pairs. So what is lone pairs? In an atom, the outermost shell contains the fully occupied subshells like s orbital, p orbital, and they will not participate in the bonding. So remember, lone pairs will not participate in the bonding. So no bonding. So those are called as the lone pairs. And those electrons which will undergo bonding, they are called as the bond pairs. So these will involve in the bonding, this one and this one. But these will not involve in the bonding. So these lone pairs are 2 in number in the oxygen. There are 2 lone pairs in the oxygen. So you can see here, I represented with a yellow. So this is one lone pair. The other one is another lone pair. They are not involving in the bond, but they can make a temporary bond and change the molecules. So remember, the lone pairs will not involve in the bonding, but sometimes they involve in the bond pair and will helpful for substituting with another molecule. You understood this? This is very important how the bond forms now. Remember, guys, please, in chemistry, don't just by heart how the reaction will happen. Like ROH alcohol, it converts into RX, which is aldehyde. Please don't do that. Just understand what is the mechanism behind why OH is converting into X, why this reaction is happening. So understand the mechanism. It is very, very important in the chemistry. If you mug up reactions, then how many reactions will you mug up? There are like thousands of reactions. So please don't jot down all the reactions. Understand the mechanism so you will not need to mug up anything. You can simply understand and you can do it. So have you understood what is meaning of lone pairs and oxygen is containing two lone pairs of electrons. Tell me these points you understood or not. Oxygen is containing lone pairs, and oxygen has two lone pairs, and these lone pairs will never undergo bonding, but sometimes it will go bonding. We'll see how it is going bonding here. Is that clear?
Yes.
Yes, sir.
If you understood this, then I'll go to this reaction. Otherwise, I cannot tell you what happens here in this reaction.
So, could you repeat once?
Okay, so we know oxygen atomic number is 8. It is 1s2, 2s2, 2p4. So 2s2, 2p4 is the outermost shell. So S is called as the subshell. P is called as, it is having subshells like px, py, pz. And we know each subshell or each orbital should be occupied with 2 electrons. So here 2s is occupied with 2 electrons already. 2px is occupied with 2 electrons. But 2py, 2pz are not occupied with electrons. So they will involve in the bonding so that the green electrons they will get and make the octet configuration. So those electrons which are involving in the bonding, we call it as the bond pairs. So py, pz containing the bond pair of electrons. Py, pz is containing the bond pair. But px and 2s, they are not involving in the bond pair because they are already filled. So we call them as the lone pairs. That means they will never make any bond with anyone. They will simply present like a lonely electrons. So they are called as the lone pairs. Understood?
Yes, sir.
Please tell me if you understood, everyone.
Yes, sir.
So can you repeat that last sentence? I couldn't hear you properly.
Okay. So here 2s, 2px, they are filled with 2 electrons each. So they don't need any other bonding to get the electrons. Okay. Whereas py and pz, they are filled with 1 electron. You can see here, whatever that I wrote with yellow, it was filled with only 1 electron. So they are looking for someone to give another 1 electron. So they are involving in the bonding. So the green one. So they got this green one because they are making the bond with 2 different other atoms. Like see here, oxygen is making bond with hydrogen. Oxygen is making bond with hydrogen. So here, whatever the electron they are getting here, those electrons are represented in the green. So the electrons which they got by bonding, we call it as the bond pair of electrons. So whatever the electrons present in the py, pz, we call it as the bond pair. Okay. Whatever the electrons present in the s and px, they are lone pair. So you can see here, I'll represent in this form. So oxygen is present like this, and it is having 2 lone pair of electrons, 1, or let's write here. So these are the lone pairs, and they are having 1 empty. Okay, 1 vacant ones. So let me write it as this one. Okay, so see here, these are called as the lone pair because they will not undergo bonding. And these are called as the bond pair because they will undergo bonding. Is that clear? Okay, let me show it again. So this is our present. This is a lone pair. This is a lone pair. And this is a vacant electron, this yellow one. Okay. And hydrogen is also having 1. This hydrogen is also having 1. So they are making bond like this. So that's why these are called as the bond pair of electrons, because they are making bond with another hydrogen. So that now this oxygen can also have a right on this electron. This oxygen also have the right on this electron. So see how many electrons are present around the oxygen. 1, 2, 3, 4, 5, 6, 7, 8. Now does the oxygen is having all the 8 electrons. So can I say it's a stabilized configuration now when it makes the bond with 2 hydrogens and make a water molecule? Is that clear, guys, or are you having still doubt in this? Not understood? It's your basics are very bad foundation. Atomic structure, chemical bonding, you should understood it very clearly. Anyways, no problem. Just you understood that oxygen is having 2 lone pairs. Just you understand this one thing. Oxygen is having 2 lone pairs, and those lone pairs are not involving in the bonding. Second one, oxygen is having 2 electrons which will undergo bonding. So lone pairs here, nothing but 4 electrons. Remember, it's a pair. So 4 electrons and 2 electrons are involving in the bonding. Is that clear? It's okay if you don't understand, no problem. This is not that much is needed. Just you should have a basic idea. Okay, so let us see. Nitya, you understood anything about the lone pair?
Sir, I understood it, sir.
Then reply, Nitya. I'm asking many times why you not answering. Please reply.
Okay, sir. I'll answer.
I don't know, like if you guys are not answering anything, then I'm thinking that you didn't get anything. Era, Srikar, నీకు అర్థమైందా?
Yes, sir. Understood.
ఒరే మరి ఏరా నో రేపు.
Writing it, sir.
Okay. So see here, this OH is a poor leaving group. So what is meaning of poor leaving group? That means whenever a atom that can break the bond with other atom and leave it freely. So suppose ROH is there, it will break the bond here and turn into R plus OH minus. So they were separated. So if that is separated, then we call it as the poor leaving group. For suppose there are two couples and the bond or relation present between them is, if it is weak, then they can easily break it. But if the relation is very strong, then we cannot break the bond. The same way here, the ROH have a strong relation that we cannot break it. So poor leaving group, that means it can never leave it. I mean, it's like it don't want to leave it. But you bring the third person between them. Like you bring one hydrogen extra here, then it will turn into a strong leaving group. So the war will happen between the two molecules and the relationship will come to an end. So they will separate it now. So R will separate with water molecule. So R is present like a broken person and H2O is formed a bond with another new person. Okay, now R is just waiting for someone to come in his life. So here we will get the halogens. So it could be the fluorine, chlorine, bromine, iodine. So and make RX bond. You understood this? Nitya? Dia, does it make any sense to you? Understanding anything little?
Sir, I am understood what you said so far.
Because this is very, very important. If you understood this mechanism, we can go the next steps very easily. That's why I'm stressing so much on this.
No, sir, I understand what you said.
Okay.
Sir, I got disconnected. Can you explain from the strong leaving group part?
1 second. Is my internet stable that everyone can hear me? Or is my voice breaking in between?
It's okay, sir.
Okay. See, what happened is there is a and B. Okay. So if B can break the bond between A, then we call it as strong leaving group. That means they can easily separate it out and find their different paths. But if the bond present between the A and B, if it is strong, then we cannot separate them easily. Okay. So in order to separate them easily, we need to do something for A or B so that one will want to leave. So what we are doing here, so R and OH, they are strongly attached. So then I am bringing another hydrogen here. So this hydrogen will make bond with OH and form the OH2. That's a water molecule. So because of the hydrogen attached to the OH group, hydrogen attached to the OH group and make the water molecule, whatever the bond present between the R and OH, that bond will become so weak. So that's why it is become as a strong leaving group after attaching hydrogen. So they will separate, R will separate, and water molecule will separate. Now R is looking for someone to come in his life. So there comes the halogen, fluorine, chlorine, bromine, iodine. So this R will date with any other guy, either the fluorine or chlorine or bromine or iodine. Okay. So that's how the reaction will happen here. Okay. So see here, what happening is, so ROH in presence of hydrogen bromide or hydrogen halide. Here also the bond will break, and whatever the electrons present here, those electrons will given to the X. Okay. So whatever the property present between the hydrogen and halogen, that property will goes to the X. Then hydrogen will become nothing. It will become like a H positive, and X will become like a X negative. That means F minus, Cl minus, Br minus, okay, I minus. So these guys are now rich because they got the property. They got the electrons here. The hydrogen lost the electrons. Now this guy become poor guy. Okay. So the same way here, when water molecule OH2 is removed, now R OH2 will leave, this will leave, and R will present like a single. Okay. So R is present like a single and R becomes a poor guy. Now this poor guy who is R plus, here F minus or Cl minus or Br minus I minus, the rich will come and woo this R plus. So it will make bond like this. So we know opposite charges will attract here, the poor and rich guy. Okay. So they make RF bond or RCl bond or RBr bond or R minus bond. So nothing but these bonds. Understood? And whatever this H plus poor guy is there, now this poor guy will go to OH molecule who is having so much of wealth. So you can see here, it's having lone pair of wealth here. So this guy will attach to this and make a bond like water molecule and leave. So see here. Understood this? So this reaction you should understand basically like this. So whenever ROH is there with the lone pairs of electrons in presence of hydrogen bromide or hydrogen halides, the bond is broken here and the electrons will go to X. So now the X will become negative and hydrogen will become positive. So this positive hydrogen will go and try to bind with the OH molecule. Okay. So when it binds to OH molecule, then it will turn out like this, OH2. So how does it will bind? Whatever the lone pairs present on the oxygen, it is given to this X. Generally, I said oxygen will not make bond with using lone pairs. But in this case, it uses its lone pair and try to attach with the H plus. Now this turns out to be positive because it has given electrons to H. So we know whenever someone gives electron, that will turn out to be positive. Give electron, turn out to be positive. Gain electron, turn out to be negative. So if you take electron from someone, you will get the negative charge. If you give electron to someone, you will get positive charge. So here the O has given electron to the hydrogen. So it turned out to be positive. And here the same way. Here whatever the electrons present between the hydrogen and halogen, the halogen has taken. So it turned out to be the negative because it has taken. And the other one is given. So it turned out to be positive. Okay. And this X minus, it is having now good wealth. So it will try to attack this R. So when it try to attack the R, the OH will leave, OH2 will leave, and the X will bind to R. So you will be getting the alkyl halide and water as a byproduct. So this is the mechanism behind. This mechanism for boards you don't need, but for NEET you need. For NEET exam, it is needed. It is important. So see here, OH. When it comes near to the HBr, so the electrons are given to bromine, so the bromine will turn out to be Br minus, and this hydrogen lost the electrons, so it turned out to be H plus. So this Br minus, this H plus will go to the OH molecule and try to attach to the OH molecule. So that will make the bond like this, OH2. And whatever this Br minus is there, it will attach to somewhere carbon. So it will attach to this carbon. Okay, so that will further make a bond into like this. Okay, so understood this. How does this happen?
Yes, sir.
So simply, in order to say this, ROH will turn out to be R leaving group, and this will turn out to be RX. So what is the leaving group here? The water molecule. Okay, so see here, whatever OH is there, it will bind to the hydrogen will bind to the OH and turn out to be OH2. Once it binds this way, now this OH will not make bond with carbon and it leaves, it exits the bond. So when it exits, here the vacancy is created. That vacancy will be occupied with the bromine. So that's how it will convert into RX. Okay. So now, general reaction, you can write this way. So I hope you understood the mechanism. So I'm directly telling how the reaction will happen. So let's take an example, CH3CH2C, which is attached to the CS3 and CS3 OH. So when this molecule reacted with the hydrochloric acid, this turns out to be CH3CH2C, and whatever this OH is there, it will leave. So CH3CH3, here it will form like OH2. Now this will leave. So when it leaves, this molecule will turn out to be CH3CH2C, CH3CH3. Here it will give the negative charge. Okay, so and whatever this HCl is there, it will turn out to H plus Cl minus. So this H plus has attached here, and this Cl minus, it will come and bind here. So that turns out the reaction like CH3CH2C chlorine. And you will be getting the water molecule here. So plus H2O. So this is the reaction, the whole reaction, how it happens. There are intermediate steps are there. So this one and this one are intermediate steps. But if you want to understand this intermediate step, you should understand the previous mechanism which I told. And finally, these are the products which are formed. This one and water molecule. So this is product 1 and 2 at the end of the reaction. So you understood this mechanism, how the general reaction has happened? Everyone? Or should I write it in detail by writing the sentence as well? So what's happening at each step?
So could you write like that?
Okay, I can do that.
So could you go to the previous slide 1 second? Not this one. No, not this one, sir. The recent one.
Okay, Are,
Oh,
we can do that later. It's already getting late. So see, what happens is, please listen carefully. So CH3CH2 C, or let me take a simple example, CH3CH2 OH. Okay, so when it reacts with the hydrochloric acid, what happens with the hydrochloric acid is it will turn out to be H plus Cl minus. Okay, so the bond breaks and chlorine gets the electrons and hydrogen lose the electrons. So losing electrons, it will turn out to be positive, and this one will turn out to be negative. Okay, so this H plus will go and bind to OH. So the proton will attack OH group. So upon attacking, Now this one will converts like this: CH3, CS2, CS2, OH2. Let me highlight this with some other color. OH2. Okay. And whatever this Cl minus is there, it's present still like this. Now see here, OH2 is like a easy leaving group. So remember this is a leaving group. So it leaves. When it leaves, it will turn out to be like this: CH3, CS2, CS2. As it left, it also takes the electron. So this will turn out to be the positive. So mention it with plus. So this is positive and this is negative. So they both will come and attract each other. So they make a bond here. So the reaction will finally goes this way: CH3, CS2, CS2, Cl. And whatever this OH2 is left, it left like a water molecule. So you will be getting the water molecule as well. So simply to say, ROH, this one, when it reacted with HCl, that's HX, it turned out to be R plus OS2. Now this is leaving, and this X minus will make the bond with this. So that turns out to be Rx plus water molecule. Understood? So this is the mechanism. This one is here. If you understood this one, whatever the reaction comes with hydrochloric acid, whatever the R group you take, you can tell the final product. That's why I'm putting so much pressure on the mechanism to make you understand. So once you understand the mechanism, you give HB or you give HF, you give any other atom here, any type of alcohol, you can tell what is the final product will be formed. Nitya, is this clear for you?
Yes, sir.
What about you, Shrikar?
Yeah, sir. I understood.
Sharan?
Little bit
Yes,
confusion.
sir.
Dia?
Understood, sir.
Okay. Okay. So next you need to know, so how does the reaction will go if it is a primary, secondary, tertiary alcohol? So what is primary alcohol? What is secondary alcohol? And what is tertiary alcohol? So if the carbon is attached to one carbon, so that type of alcohol is called as the primary alcohol. So you can see here, it is only attached to one carbon. So this carbon called as the primary carbon. So when we say primary carbon, if it is attached to one R group. Secondary carbon, if it is attached to two different R groups, then we call it as the secondary. So R1, R2. So this carbon is said to be the secondary carbon. And this alcohol is called as the secondary alcohol. So you should know what is primary alcohol, secondary alcohol, and tertiary alcohol. So tertiary means which is attached to different R groups. So R groups are nothing but, they are nothing but the carbon itself, the carbon chain. Okay. So this is called as the tertiary carbon, which is attached to the alcohol. Understood? What is meaning of primary, secondary, and tertiary? So what happens? You should know. So in the reactivity order, first one, hydrogen halide is stronger reactive than hydrogen bromide, and hydrogen bromide is stronger reactive than hydrogen chloride. And if you come to the reactivity of ROH based on which alcohol it is, whether it's a primary or secondary or tertiary. So the tertiary alcohol is more reactive than secondary alcohol. Secondary alcohol is more reactive than primary alcohol. You should know this is very, very important. The questions can ask like this. So they give reactions and they will ask which will be the product is formed. If it is a tertiary, is more reactive, so the answer will be the tertiary. If the answer is not included tertiary but secondary and primary answers are given, then you will take the primary. If primary is not given, then you will be taking the other one. Okay. If not secondary, then you will be taking the primary. Reactivity means those which are ready to make the bond. Okay. And remember, to speed up this reaction, we also use another catalyst that's called as the zinc chloride. So this is very, very important. So remember, you will be using the anhydrous zinc chloride as a catalyst to increase the rate of reaction. Increase the rate of reaction. Okay. So remember this, tertiary is more reactive than secondary is more reactive than primary. As well as the hydrogen iodide is more than Br than Cl. That means you are going down the group, the reactivity rate increases. We know fluorine, chlorine, bromine, iodine. As you go down the group, the reactivity increases. Okay. So remember this point. So see here, what happens with alcohol? ROH, when it is primary or secondary. When primary or secondary, you will be using the zinc chloride to give RCl plus water when you treat with HCl. Okay. But when it is tertiary, you doesn't need, it can react without need of HCl. Okay. Can react without ZnCl2. Why? I told you in the previous, the tertiary is very reactive. So it doesn't need a help of zinc chloride catalyst. So it can react without zinc chloride catalyst. Okay. So remember ROH, if it is primary and secondary, it need the help of zinc chloride catalyst. But if it is a tertiary, it doesn't need the zinc chloride catalyst. Okay. So remember that one thing. And remember here, so you are using, in this what you are using? You are using the hydrochloric acid. So you are using HCl as well as you are using the zinc chloride. Yes or no? So you are using HCl as well as you are using zinc chloride. So the mixture of the hydrochloric acid and anhydrous zinc chloride, so we call it as the Lucas reagent. So remember, this is anhydrous and this is concentrated HCl. So this mixture, we call it as the Lucas reagent. So they can ask what is Lucas reagent or what is use of Lucas reagent. It will be helpful for forming the alkyl halides using alcohol. So remember, Lucas reagent is useful for making alcohol making alkyl halides using alcohol with hydroallic acid. So that is the use of the Lucas reagent. Remember this. Is this clear?
Yes, sir.
So just write down what is the definition here. Okay. So what's the use of Lucas reagent? So alcohols with HI and HBr. So remember, this HI and HBr are often generated from the allied ions and acids such as phosphoric or sulfuric acid. Okay, so you are getting HI, you are getting HBr. So where you are getting this HI and HBr? You are getting this in presence of phosphoric acid or sulfuric acid. Okay, So sulfuric acid is H2SO4 and phosphorus acid is H3PO4. So remember this. This is H2SO4. This is H3PO4. Okay. So only when you are generating from the allied ions. Okay. Remember this H2SO4 and H3PO4 only when there is a allied ions. Okay. For suppose,
Sir, voice is breaking.
is it breaking?
Sir,
Okay.
it's proper, sir.
Then it's not my issue. So remember this reaction. So CH3, CH, CH3, OH. So in the presence of H bromine, you will be using the H2SO4. And you are using sodium bromide. So the sodium bromide, let me wait. Yeah. So see here. So we will be using two things. One is we will be using NaBr and we'll be using H2SO4. So NaBr will turn out to be Na plus Br minus. And H2SO4 will turn out to be H plus HSO4 minus. So now see here. This Br minus and H plus, they are opposite charges. So they will result in HBr. And NaHSO4, they are opposite charges. So they will turn out to be NaHSO4. So that's how you are getting hydrogen bromide. That's what he's saying. Hydrogen iodide and hydrogen bromide are generated by using the allied ions. So here the allied ion is Br minus. How you got that allied ion? By using the sodium bromide. Okay. And in presence of sulfuric acid. So you can see here sulfuric acid is H2SO4 that turned out to be H plus HSO4 minus. Okay. So this reaction can be written like this: CH3, CH, CS2 or CS3, OH. So in the presence of concentrated HBr, using the Na, Br and H2SO4, you are getting CS3, CH, CS3, Br. So I know you guys, you will directly remember this this reaction. So we are using NaBr and H2SO4, but you don't have any idea why you are using NaBr and H2SO4. So you are using NaBr, H2SO4 in order to create the HBr. So that's how you will get here HBr and NaHSO4. And then you will be getting the CS3CH, CS3 bromine. Okay. And remember, we cannot generate HI using the sulfuric acid here. You can see here, you only use the phosphoric acid, but not the sulfuric acid. Because sulfuric acid will act like a strong oxidizing agent. Instead of it making HI, it turns out to be I2. So that's why we will not use sulfuric acid. Okay. If we use sulfuric acid, we will not get the HI. We will get the iodine. They can ask in MCQs. So can we generate the Ki using the sulfuric acid? Can we generate using the Ki and sulfuric acid? No, you cannot. If you synthesize that way, you will be getting I2. But if you can synthesize Ki and S3PO4, you will be getting HI. So you can do this. So remember, what is our ultimate thing? We want some halogen, hydrogen halide. That's HI. But if I use sulfuric acid, I'm getting I2. So no use of using it. So remember this. Okay. So concentrated sulfuric acid being a strong oxidizing agent, it oxidizes and produce iodine. That is I2. So hence, we cannot use sulfuric acid with potassium iodide. See, with potassium iodide only, we cannot use. In this previous, we used the sulfuric acid, but at that time it's an allied ion, not a potassium iodide. But here it's a potassium iodide, so I cannot use a sulfuric acid. So this is a thing you need to remember. They can ask in NEET. Okay, is that clear? So why can't we use the sulfuric acid with potassium iodide for preparing the alkyl halides? So next exception is this one. Aryl halides cannot be prepared from the phenol. So what is phenol? It's nothing but the benzene ring with double bond attached to the OH. Okay, not double bond, with the OH. It is attached to OH. Okay, but if you see here the oxygen is making a partial double bond. So there is a partial double bond. So due to this partial double bond, the bond here is very strong. It is very strong. Hence we cannot break. So difficult to break. So as it is difficult to break, so you cannot create a alkyl halide here. So you cannot create alkyl halide here, aryl halide here. So in order to create the aryl halide, first you need to break down this bond. Once you break down this bond, then it will turn out to be X, aryl halide. But this reaction is not possible because whatever the bond present here, it is having a partial double bond that is very strong and it is very difficult to break. So you cannot derive the aryl halide using the phenol. So that, remember that one thing. Okay, I think we'll stop here. Using the phosphorus halides and thionyl chlorides, we'll continue in the next class. I think already you guys are overwhelmed with a lot of information. Is it right, Thea? Or you have energy to continue the class?
That's fine. Whatever is good for you.
What about you guys? Tell me. If you are okay, I'll continue. There's just only a few slides. If you feel, let's stop here, I'll stop here.
So could you teach in the next class?
I expected this answer from you. What about you, Nitya?
Anything is fine. If you're teaching now, also it's fine.
Okay, just it's a 3 slides. We'll continue it. So how do we do using a phosphorus halide? So any idea what is phosphorus halide? Can you name one example? Having phosphorus halide means you are having phosphorus and some halide group like chlorine. So any example with this group? Okay, let me give the PCl3. So mostly phosphorus halides are like this, PX3 or PX5. Okay. So PX3 or PCl5. So you can take the example like PCl3, PCl5. So how do we prepare? So let's take the reaction. So 3ROH in presence of PX3, it will convert into 3RX plus H3PO3. Okay. So let's take example like 3ROH. Example in the sense, in place of X, I'm putting some chlorine or fluorine or anything. So PCl3, that will convert into 3RCl plus H3PO3. And remember, here the X could be chlorine or bromine, or you can also use iodine. Okay. So if you see the mechanism, how it happens. So there is a R group. Sorry, there's a phosphorus. The phosphorus is having 3 chlorines, 1, 2, and 3. Each chlorine will be attacked with 1,1 alcohol group. That means it will come close to ROH. Here it will be attacked with ROH, alcohol group. Here it will be attacked with ROH. So that result in making a bond between the R and Cl. And you left out with the phosphorus and OH and OH and OH. So they will all make one bond here. So whatever the white one, they all will make one bond. So we know phosphorus can attach to 3 atoms as it attached here, 1, 2, and 3. So it can attach with 3 different OH groups as well. So that will turn out to be ROH, ROH, sorry, that turn out to be P attached to OH, OH, and OH. So let me write better. So P is attaching to all the different OH groups. So OH, OH, and OH. So that's nothing but H3PO3. And you will be getting the red one as 3RCl. So you see here, this is 1, 2, and 3. So that's why it is result in formation of 3RCl and H3PO3. You understood how this mechanism has happened? So just break the bond between the phosphorus and chlorine. So you break the bond here, you break the bond here, you break the bond here. So now the chlorine will try to bond with R in the alcohol, try to make a bond with R in the alcohol. And now the OH become free. So these all OHs will try to go and attach to the phosphorus. So that's how it will turn out to be H3PO3. And all these RCl, 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 so you will be getting as 3RCl. So that's how you will be preparing the allo compounds using the phosphorus halides. Somewhat slightly different happens with PCl5, because in PCl5 all the chlorines are not breaking the bond. So ROH plus PCl5 will form RCl. Here you will also get hydrochloric acid and you will also get POCl3. So how does this bond happens is, you can remember like this. So PCl3 you write in this order. So PCl3, it is attached to Cl and Cl. So that's making PCl5. And you take this alcohol ROH in this way. So let's take example here. The alcohol CH3CH2OH. Now this PCl3 will try to bond with O. And whatever the R group present here, that will be bonded with Cl. So CH3, CH2, OH. You know, right? OH, this is OH. So the bond will happen between the PCl3 and O. Another bond will happen between the Cl and H. And another bond will happen between the Cl and CH3CH2. Which will result in giving CH3, CH2, Cl. This one is giving POCl3. And this one is giving HCl. So that's how you are getting different products, RCl, HCl, and ROCl3. So you understood how this happened. Next one, how do we prepare using the thionyl chloride? So what is thionyl chloride? It is nothing but SOCl2. Remember, wherever you see the SO, it is called as the thio. Okay, so thionyl chloride. So here the thionyl chloride can be prepared as alcohol in presence of SOCl2. Here you are using the pyridine as a catalyst. Remember this. They are very important for NEET. They can ask what is the catalyst used? Pyridine. And you eat it. So add some temperature. You will be getting the product as CS3, CS2, Cl. So my alkyl halide is common. This is alkyl halide. And what else the byproduct you will get is sulfur dioxide gas, and you will be getting hydrochlorine gas. So remember, these two will come as a gases. Okay. So these two will come as gas. So how does this reaction will happen is, first suppose you take SOCl2, the SOCl2 can be written as SO. It is attached to two chlorines on either side. And ROH, R is on one side, O is on one side, and H is on one side. So the bond will happen this way. So between SO and O, between R and Cl, and between Cl and H. So this turn out to be HCl, and this turn out to be SO2, and this turn out to be RCl. See, almost it's same for before one also. You can see here, it's RCl, and whatever the middle part, it's binding with O, and whatever the hydrogen, it's binding with the end part, Cl. The same way here also it happened. So that's how you will be getting hydrochloric acid, sulfur dioxide, and RCl, which emits like a gaseous. So as here you are getting the gaseous, so this is very good method for preparing the alkyl halides. So remember this thing. So there's a note. As here you are getting the gaseous, it is very good method for preparing the alkyl halides. So good method for preparing alkyl halides as you are getting gases in nature. So this is very important. So this is a very good method to make the alkyl halides. So that's it for today's class.